the final like selling point for you guys really is that you guys are WA based. You're here in Australia doing the work. Expect like, you know, most synthetic chemicals that are done, so synthetic feeds of graphite, they're all based in China. You guys are here, the research is here, the IP is all yours. Why don't you tell us a little bit about the process of like starting that up, getting set up in WA to be a WA certified manufacturer of synthetic graphite?
Yeah, so Australia does a lot of graphite mining. In fact, we have a lot of natural graphite deposits.
Yeah, as WA does, we mine things, yeah.
we love to dig things out of the ground, but we don't have the technology aspect of making synthetic graphite. So as I mentioned, we developed this technology through, it was more fundamental blue sky research back in my PhD. We were asking the question of why it's so difficult to make graphite, synthetic graphite. And once we answered that, why it's so difficult, we did the catalyst stuff, and now we're spinning out of Curtin University and starting to scale production. So we're about to start a pre-pilot of this in collaboration with Curtin University. We'll be piloting our process at sort of about the kilogram per day scale, starting in 2026. Early 2026 is the kickoff date for that.
Cool.
We expect to be able to produce our own batteries using that. So WA made graphite going into a lithium-ion battery.
Yeah, WA made cell. I mean, it's a pretty good sales pitch from that perspective, yeah.
So we'll actually be doing that work with the National Battery Testing Centre over in Queensland. Essentially taking our WA-made graphite and making it into an Australian-made cell and testing it there. From there, we look to then start moving towards commercial demonstration, producing more and more graphite and scaling production, because it's this obvious thing in the green energy transition is that we need more lithium-ion batteries, which means that we need more of the components
and
that
a
go
lot
into
more graphite there.
For graphite, it looks like a 9 million tonne shortage by 2035, and there's no real way in which we can meet that. Current technologies, just commissioning new mines takes sort of around about 15 years to get a mine from exploration through to production, and the way in which graphite's made the old way that China does it is not something that can be deployed really in the West. Just environmentally, it's a catastrophe.
I was going to say, like ethically, environmentally, everything. There's problems all across the board with the current conventional method of synthetic graphite manufacturing, and I suppose you've got the other problem as well, is that even if we could do that in Australia, then we're still 20 years behind setting up all those processes. We don't know how they're done. We'd have to then work all that out. And then we'd be doing all that to then generate it in a way that is not environmentally sustainable. So hence it's a really important stream is this this eco-centric rapid graphite technology that you guys are doing.
The reason for scaling lithium-ion batteries is around the environmental aspect, right? Like the green energy transition. Now you can't transition to green energy if the way in which you're doing it is not green.
Of course, yeah.
So the fundamental side of it was, for us, we developed technology that allowed us to make graphite in one of the most sustainable ways that we could see possible. Like globally, we identified that we had a really unique piece of technology that could help in this area. So for us, a big driver at Rapid Graphite is just around how can we do this better, and how can we scale up our technology quickly to meet this shortfall in supply. We know that the demand's there, and we know that there's a real question about how the world supplies a sustainable graphite for the batteries that we all need. And so we're working really hard to try and scale up and meet that demand. Yeah,
cool. So I suppose it's just like easy way to circle back to the start then is that to highlight the importance of graphite in lithium ferrophosphate batteries specifically, 60 to 70% of our cell is all graphite. Our anode is completely graphite. And then I suppose without, as you've said, that shortage of products is going to cause, we've seen the lithium price crashing, which has then also brought down the price of our batteries and everyone else's on the market. But with graphite then becomes this finite resource that we're not going to be able to sustain the production despite the fact that lithium is now quite, I wouldn't say it's an abundant resource, but it's definitely more available than it was previously.
Certainly. There's a good supply of lithium, and there's not a great supply of graphite. But graphite can't be substituted in a battery either.
No, exactly,
So like you said, the anode side of the battery is graphite, and,
Yeah.
and that's whether or not it's an LFP or an NMC or
That's exactly what
any
I
other
say. Yeah,
chemistries.
lithium titanium oxide. I mean, I'm not entirely sure about the sodiums. I imagine it's probably going to be something similar because of the profiles of graphite. There's a reason we're using it. It's because it is great. Like for the electrical energy exchange, it's what we need there.
It's still, for sodiums, it's still a carbon, not quite a graphite, so it's
Okay.
not that ordered stack layering of
Yep.
graphite. It's more of a porous carbon.
Okay.
Sort of from the spectrum of our feedstock that we start with to graphite, it's more towards what our feedstock will
Oh, okay,
start
really?
with,
Okay.
actually. Yeah.
That's cool. But yeah, I suppose that doesn't really help with the lithium sector because we do need the ordered graphite. Well, thank you guys so much for tuning in. This has been Luke from Gen Z and Jason from Rapid Graphite. And yeah, thanks for your time.
Thank you.